and then I'll put it up on YouTube and send you a link. That way, if there's anything that you're like, wait a minute, what did she say about that? So anyway, your mom said that you guys were that you were having a really good time trying to learn Algebra 2 all by yourself. And so let's see what we can do on this one. So I'm going to pull this over here. I think this is an easier, oh, where did it go? I think this is an easier way to think of the functions. So instead of that table that's on that worksheet, I think it's easier because it's way more visual. So you have your y equals, and then you have your function. And of course the f just means function. It's not like part of the equation or anything. You're okay with that? Okay. And so anything that's in front here, that's going to be a vertical reflection or a vertical stretch or compression. So our reflection, if it's got a negative number, and then it's going to be a stretch or a compression depending on how big it is. So, oh, there's somebody else.
Okay.
Can you see it?
I'll use the internet auto down here.
Okay. And then the H, what's weird about the H and the K?
Can you hear us now?
Right. Ooh, that's bad.
No, we
Are you
lost.
talking?
Can you hear us?
Oh, now she went away.
Oh, sorry. I shouldn't.
Darn it. Now, see, that makes me think there's something, hold on. Makes me think there's something wrong with mine because, oh no, that one's muted. Just a second. Oh, now she went away. Gotta love the technology. I'm not in a hurry. Like, I don't have anywhere to go, so.
Okay.
Okay, when she gets the phone hooked back up, it looked like it was working. It was just muted. So we'll see. There's only one other thing I can think of. I did unplug a speaker yesterday, but I'm not using the speaker. I'm using my earphones, so.
Have some water?
Just hear it on.
Okay, it says iPhone's connecting to audio.
Can you hear us? Can you hear us?
Can you hear us now? Can you hear us now?
Can you hear us?
She was not hear us.
I'm just gonna leave one more time, and I'm gonna press the dial.
Yeah, it doesn't want to stay connected. Darn it. I just wish you guys could talk to me so that you could ask me questions. Okay. So let's wonder why it keeps connecting. It must just be that the signal's not strong enough. Oh, somebody said something in the chat.
Okay.
Yes, you can use the chat. It's just a little harder to see the chat, but it's better than nothing. So, okay. So let me go back to share screen.
How are you? Oh my gosh.
Hold on. There we go. Okay. So, okay, so the iPhone's connected. Try talking. Hello, hello. Okay,
Hello?
I'm gonna try one thing because there's only one thing I've changed on my computer since I did Zoom last. I don't know why it would affect it, but I'm gonna go see if it is.
Can you hear? Can you hear me? I will. Somehow. I don't know how, but I Oh, such Shiggy's our little Asian tech. Good job. Try to put these in the computer. See if you can. Let's see.
No. Don. Or no. I mean, they're Omis. And I don't want him to have them no way.
Haha, I can hear you. That was my speaker I changed. I don't know why it affected my headphones, but I can hear you guys now. Sorry. Okay, so we're in business.
I thought we can't just talk to her on the phone.
Can you guys hear me now?
Can you hear me?
Yes.
She can hear me.
Yay. I think it was my computer, but I don't know why it was my speaker that I had changed. I don't know why it affected my headphones.
Take it
But
out.
I don't care. We can hear each other.
No.
That's all that matters. So,
Take it out.
okay. So you don't have to worry about the iPhone because I'm hearing you through the computer. So you don't have to worry about it. We can just,
Okay.
yeah.
Can you hear me now?
I think it was my computer. It was something I changed with my speakers that I didn't think would affect my earphones. Okay, so on this thing, back to this, anything in front, if it's a negative, it's going to do a vertical reflection, which is
And
a
then
vertical reflection is going to be
I take notes.
uh,
I just don't know how to do like this part.
so a vertical reflection means it's going to reflect it not horizontally, but this way, like
Yeah.
up and down. Okay, so vertical reflection. And then what's weird about the H and the K, and really they should have this backwards because the plus here makes it go left and a minus makes it go right. And then on the
opposite of what you think.
opposite of what you think. And there's a reason for that. The reason for that is because this is right with the X, it affects it in the opposite way. If you think of this, if you put the K over with the Y, it would do the same thing. If you put the K over here, AF X plus or minus H, if you put it over here, it would affect the Y opposite. It's just that they solve for Y and put it over here, and so then it makes it so that it's not opposite. So when it's right with the variable, it always is opposite. It's just that this one gets moved over here, so then it doesn't affect it opposite anymore. So that's why that happens. So the X is affected opposite, but the Y is affected directly. So you're kind of okay with that? Okay. So if we look at this worksheet, let me get rid of this thing.
Isabel.
So on this one right here,
Just stop.
they're trying to, let me get something better to write on. Actually, this isn't too bad. Okay, so when we're looking at the one that they give you here, what I always tell students to do is graph the original like function without any of the changes first, and then start applying the changes, because it's really hard to just look at the numbers here and do it. It's a lot easier if you look at the points themselves. So if you take this one right here that they have, you notice it's a cubic. Did you guys ever talk about the parent functions?
That does sound familiar, but we had a sub for like the last 9 weeks, and we didn't really get a touch on that, I think.
Oh Lord, so you had a sub and then you had to go to
He had a
homeschool.
teacher, and then he got sick, and then they had a sub, and then we had the quarantine.
And then you had the quarantine. Jeez.
And
Okay.
then it went back to the teacher, but he didn't teach anything. He just sent links.
Okay. So the parent function is like the basic function. So like in this case, it's got a cubic on it. And
Yeah.
so that means the parent function for this is like g of x equals x cubed. So the parent functions are like f of x equals, well, x would be like a line. F of x equals x squared would be, you know, anything that's a square. And then this one is f of x equals x cubed. You probably did some other ones. Did you, or did you not do any other ones besides lines and squares and cubes? Is that all you did?
Yeah, like that's basically all that looks familiar to me.
Okay, okay, that's good then. So you need to notice like which of these it is first. So in this case, it's a cubic. And so I always tell students, start with that. So you're going to start with the parent function. That's like the first thing you want to do. And so just graph f of x equals x cubed. And if you know, so you could just think of some points in your head, or if you're a more like a visual person, maybe you want to, you know, make yourself a little table. But y equals x cubed, if you put in like a -2, -2 cubed would be -8. You okay with that? -2 times -2 times -2?
Yeah.
Okay. And then -1 would be -1. -1 times, you know, -1 cubed.
Mm-hmm.
And then 0 cubed, of course, is just 0. And then the only thing, when you get to the 1 and the 2, they just are positives instead of the negatives. So these points would all be on the graph. So
Okay.
I would just graph those first. So -2, 3, 4, 5, 8 is down here. -1, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. And then there you go. So it would look like this originally before all the translations and such.
Mm-hmm.
So that's like our starting point.
Okay.
And you've got to really know that before you can do anything with it. So you have to recognize that, hey, that's the main shape of and the starting point for the graph. And then all these numbers move off of that. Does that
Okay.
make sense? Okay. So so then like that little picture said, you're going to start looking at all these things and figure out what it does. You want to start on the inside, just like when you're simplifying the expression, you like start on the inside and then work your way out. And so it's going to take, it's going to shift it left 1. So let's write this down. So left 1, and then it's going to, hold on a second, and then it's going to multiply by 2, and then it's going to move it to the, it's going to move it down 2. So you guys,
Yeah.
you're okay with all that?
Yeah.
So it's going to left 2, then doubled, and then down 2,
Okay.
or left 1, down 2. And what it means by double is it's going to like, it's going to move like twice as far away from the x-axis as it was, because it's doubling the y.
Okay.
So, so what did they do there? Okay, so so if you look at this original point, this -1, -1, and you start doing everything that it says, we want to move it. I'm going to do a different color so you can follow along. So if you think of the -1, -1, that would be that one, I guess.
Mm-hmm.
I'm trying to figure out what they did here. -1 plus -1 is -2. Wow, that's a really weird way to write it. I don't like this worksheet at all. Okay, so what they've done here is they said that they're gonna stretch it by 2 and then move it down 2. That's what this means. But man, that's not explained very well. I'm so sorry that you're doing this. I know this isn't my fault, but I still feel horrible on behalf of all math teachers. Okay, so what this is going to do is it's going to, if we just forget this, I don't even know what they're doing here. I mean, I do, but it's ridiculous. Okay, so take your point, and I'm going to start with this one just because it's up at the top. So we're going to move left 1. We're going to double how far it is from the axis. And then we're going to go down 2. So if you follow that, that's left 1, double how far it is from the axis. So it moves it from 1 up to 2.
Mm-hmm.
And then we're going to shift it down. So that point ends up there.
Okay.
Does that kind of make sense?
Yeah, and
So
that's
that's that one right there. Okay, so now let's do that with the other one. I'll just do a different color. We'll do purple here. Okay, so the one that was at 0, 0, you want to move it left 1, double how far it is from the y-axis, which it's already on the y-axis, so that doesn't affect it, and then down 2. So it goes to there. Does that make sense? Let me do something with the colors. So the one that's circled green got moved to the green point. Does that make sense?
Mm-hmm.
And then the one that's circled with purple got moved to the purple spot. Left 1, you move it double off of the y-axis, but since it's on the y-axis, that doesn't do anything to it. And then down 2.
Yeah.
Okay, so we got 1 left. So let's do, I don't know, we'll do this blue. Okay, so this one right here that's the -1, 1, 1 that we were starting with before, but I skipped it. So now we're gonna go left 1.
Okay.
Double how far it is from the axis. So it was at -1. We're going to put it at -2, and then we're going to move it down 2. So 1, 2. Does that make sense? So our points are. Oh, I've moved that too far. Just a second. Okay, so where were we? We were here. We're going to go left 2, double how far, and then go 1, 2. Yeah, so here. It's hard because my graph is messed up. But anyway, it's right there. It's there. So this one's at -4. Like I said, it's just hard to get it in the right spot with this junky. Okay, so this one it was at -2 and now it's at -4. 1, 2, 3, 4. So it's like right there. Does that make sense? So you've got one that's at doesn't look right. Just a second. This is the one that's wrong. No, it's not. I guess it's just the graph is just a little bit off. 1, 2, 3, 4. I guess it's all okay. So we're at 0, 0. This purple one's at -1, -2, and this one's at -2, -4. So it's, let me mark it out over here. It's just hard with my junky graph to be in the right spot. So this is the blue one that we did. The purple one is this one. And then the green one is this one. You okay?
Yes.
Okay. So this one, the green one started here, went left 1, doubled how far, and then down 2.
Okay.
Okay. And then this one started at 0. It went left 1, stayed put, down 2. And then this blue one started at -1, -1. It went left 1, doubled how far it was from the axis, and then down 2. And the order matters. If you move it down 2 and then double how far it is from the axis, that'll mess it up. So you have to do it in this order. You have to do that one, then that one, then that one. And how you know that is because, again, it's like order of operations. You do the parentheses, and then you do this multiplication out here, and then you do the -2. So you like start from the inside and go out.
Mhm.
Does that kind of make sense?
Yeah, so I really understand like the step 1 and number 3, but how, like, is it, for instance, can it be like tripled or what have you?
It could. So like if this was a 1/2, you'd bring it into towards the y-axis half as far as it was. So like if it was at 4, you'd bring it into 2.
Mhm.
But
Or like
since,
-3?
yeah. So like if
Okay.
ours was, so like if ours, like this one, it said to double it. So like when we moved that, we moved this one, left one, doubling it, it was at 1, and so we moved it to 2.
Okay.
If it was at 2, we would have moved it up to 4. So we double how far away it is. Does that make sense?
Yeah. Okay.
Yeah, I know that one's the hardest one. I mean, the shifts are easy. Left 1, down 2, that's not so bad. The doubling gets a little weird, but it's how far it is off of that axis. So so if it's 1 up, you move it 2 up. If it's 2 up, you move it 4 up because it's supposed to be doubled. Let's do another one, then maybe
Can
that'll
we do number
help.
1?
Yeah, what am I missing here? I think I had this zoomed in too much when I snipped it. Just a second.
Should be 3 problems at the bottom.
Yeah, I've just got it zoomed in and I can't see them. There we go. Okay, so we've got, let me clear this all out. Okay, so on this one, we've got, again, it's a cubic. So we're going to start with that basic graph of a cubic. So that's actually always the first step, is what's the parent function? And graph that parent function first so that you have a starting point. Okay, so this is a cubic. So again, it's going to be 0, 0, 1, 1, 2, 8. And so it looks like this. Okay, and with cubics, they usually only have you do these 3 points because the 8s are so far out that, it starts to get a little weird.
Okay, write that down.
Does that make sense though? So that's like your original. Ugh, that looks horrible.
She did 0, 0.
Sorry. Yeah, so this is again, it's like -2 gives you -8. That's the one down here. And then -1 gives you -1. And then 0 gives you 0, 1 gives you 1, and 2 gives you 8. So 1, 1, 2,
So
8.
you're only choosing these just because they're easy to work?
Yeah, just the ones that are around the origin. I mean, if we go past 2 and -2, we're all the way up to, 3 cubed is 27. So we're like way up at 27 already.
Okay.
So with a cubic, you're really not going to go much further than this because it's just too high up.
Oh, not yet.
Okay, so let's see what this one does.
No, that one's up there.
So this one, if we go through and we
Did you want one of the kids get me a pen?
list everything that happens.
Can one of the kids get it? No, not you. One of the kids can get it. Okay.
So which of these is going to happen first? You've got this -3 on the outside, -4 on the inside, and a +1 on the outside.
Aren't you going to shift it first?
Yeah, the -4 shift or the 1 shift?
The -4?
Yeah. And that'll move it left or right?
Right.
Okay, so that's going to move it right 4.
Mhm.
And that'll be our first one.
Okay.
And then then you're going to go to this one that's outside. So what's that -3 going to do to it?
Is it going to move like 3 spots away? Or, but then it's negative. So does it mean it's going to be like closer to it?
It's going to be, no, that would be if it was a 1/3, which it
Okay.
doesn't look like they're, oh yeah, they do. They have one here on number 2.
Yeah.
like the 1/2. Okay, so this one, it's still going to triple it. The negative does a reflection.
Okay.
So it's going to
Oh,
be,
yeah, right. The reflection.
yeah, so it's going to be reflected and tripled.
Okay.
So the first thing is it's going to move right 4. And then the second thing is it's going to be reflected and tripled. And then the third thing is it's going to be up 1. And you got to do it in that order.
Okay.
Okay, so which, see, I don't know. They don't anyway. All right. So so we're going to take and do, you know, the 3 points that they're asking us for. They're only asking us to look at -1, -1, 0, 0, and 1, 1. So those are the only ones we have to worry about. So I like to start with the 1, 1 just because it's, I don't know, because it's at the top. It makes more sense to me. So this one, we'll circle it again. So that's the 1, 1. And we're going to move it, you said right 4. Oops, got to add some marks here. Okay, so we're going to move it right 4. So that'd be 1, 2, 3, 4. And then we're going to move, then we're going to reflect it and triple it. And that one, it doesn't matter which one you do. They both kind of happen at the same time. So reflecting it would put it like over.
Mm-hmm. Wait, hold on.
So you okay with that? So like it goes from 1 down to -1. That's the reflection.
1 to -1.
So you're going to go 1, 2, 3, 4 right.
Mm-hmm.
Then you're going to reflect it, which means you're going to bring it down here. So instead of being at 1, it's going to be at -1.
Okay.
And then you're going to triple it. So instead of being at -1, you're actually going to be at -3.
Oh, okay. Then you just drop it down like that.
Yep.
Okay. Okay.
So we went, let me get rid of all these extra dots. So we went 1, 2, 3, 4 right for the -4. We
Mhm.
reflected it down to -1 because it was a reflection because of that negative in front of the 3. And then you triple it. Since it was 1 away, we're going to make it 3 away. Oh, and then we still have one more thing, don't we? Then we have to bring it up 1. So it's actually not there, it's actually there.
Mm-hmm. So it would be at 2.
1, 2, 3,
Negative 2.
4. Yeah, -2.
On a negative
3,
two.
4, 4, -2. I hope that's right. That should be right. That's when you put in a 1, right? 1, -4, be -3.
Okay, so this is 0, 0 then.
Hold on a second.
To the right 4, which would be 1, 2, 3, 4, right?
Mhm.
And you have to go up 1. See the triple, like how do I?
Yeah, and I'm wondering if,
Like, is when I say reflection, it's like a reflection over the x-axis?
yes,
Okay.
because it's vertical. So vertical means up and down.
Right.
I know it's weird because it goes over the horizontal axis, but it's going up and down,
that's
so
what's
it's
getting me.
vertical.
So when it says triple, so I would go above the x-axis?
Yeah, and let me check this really quick.
Okay.
I haven't.
0, 1, 2, 3, 4, and then I would have to go up.
I would have reviewed this a few times myself just to double check I was remembering everything right. If I
Should I
had.
count that as like, so should I count this as like 1 and then 2, 3, or like 1, start here and then go 1, 2, 3? You know what I'm saying? Okay. So,
You don't have a crafting paper anymore?
no. Mm. It should be.
Yeah, see, something's wrong with that. Maybe I'm doing the order wrong. Hold on just a second. Like I said, I would have, normally if I had planned to tutor you, I would have taken a few minutes to look this over. Stretch. Horizontal. It looks like they're doing the, hold on one second. Horizontal stretcher. Because when I put a,
Wouldn't that be a vertical?
it just isn't,
Come back to me.
I want to make sure I'm telling you the right thing because I certainly don't want to confuse you more. So what are we at? We're at negative, it'd be 1, 2, 3, 4, 5, -2.
What? Yeah. So.
Oh, okay. Yeah, that's right. That's right. Phew. Sorry. I looked at something. I was doing it on my graphing calculator. I looked at something wrong and I'm like, oh my God, I'm completely wrong. Okay. No, that's right. Okay. So did you have a question? I'm sorry.
No, I think I was just, while you were doing that, I was trying to see about the 0.00.
Mm-hmm.
So I started at the origin and then
Yep.
moved, I would do this first. I would move 4 sides to the right.
Yep.
Okay. And that would take me, then that would take me to 4. And it says to go up 1. So that would take me to 4, 1.
Yep. You got it.
Okay.
Because the reflection, all this reflected and tripled stuff doesn't affect if you're already on the x-axis.
Okay.
So,
That's important to know.
yep.
Okay. So it would just be 4, 1.
Yep.
It
And that's
would?
what they were trying to say right here. You
Okay.
notice on that one, it said it goes to -1, -2, but they don't explain it. It just gives it. It's like, are you supposed to just
Right.
miraculously understand
Well, see,
that?
I think I was confused because when it said tripled, I was like, oh, okay. So that mean I take the 4 plus 3, so I move over to like +7?
Yeah, no.
Don't do that?
It's how far you are off the axis. So this is tripled. When I say tripled, like it's how far you are away from the y-axis.
Okay. Okay, but for 0, 0, the new point would be 4, 1.
You got it.
4. 1.
Yep.
Okay.
Okay, so let's do the last one. Pick a different color here. We'll do orange. Okay, so start with this one.
Yes, thank you. -1, 1. Okay. So can I go can I go up first?
No, you have to do this order. You got to go right, then do the reflection and the triple, and then go up 1, or it'll mess it up.
She said that was an order right there.
Okay. So
So we're going to go 1, 2, 3, 4.
okay. So like +3.
Mm-hmm.
Where's a +3? And then go up 1?
Well, then,
No, I would technically be at negative. No, I wouldn't be. What? That's +3, -1 is where I would be, right?
Yep.
But then I go up.
well, don't forget the reflection.
Remember? Right? The reflection.
So you got to do the reflection. So you got to bring it from being below to being above.
So just like, would it be?
It's like a,
So it's
like
3,
keep going like
3,
that.
1.
Yep.
3, 1. Okay. 3, 1, and then up 1.
Yep.
So 3, 2.
You got it.
And that's it.
That's it. So it was here and, oh, did you triple it? You didn't triple it. I'm sorry.
Okay. So
You reflected it. Now we have to triple it.
okay. So 3, 2. Okay. So then move it up 3 more places.
Well, you're at 3, 1, and you want to be 3 times as far away from the y-axis as you are. So you're only 1 away from the y-axis now, so you want to be 1 times 3, which is 3.
So it should be 3, 3.
Mm-hmm. And then you have to move up 1.
Oh, so 3, 4.
Yep. So you have to do all those things to it.
Yeah, I think that's what was confusing me. It's because like the translations I can do, like I can easily move it. Like okay, you move it to the right or to the left, but when it comes to the reflection and tripling or doubling or whatever, like it really confused me.
Gets you,
I
yeah,
wasn't
it
sure
gets
what
you
that was
messed up. So let's do that one again. So we were here, we moved 1, 2, 3, 4 right.
3, 4.
So
Okay.
that's done. Then we have to reflect it and triple it. So reflecting it just brings it up top. But then you have to triple it. So since it's at 1, we have to move it to 3. And then you have to go up 1. We were done there. So we were at, when we were done with that, we were there. But then we have to move up 1. So that's our final spot.
Okay.
These are not easy. They really aren't. You are not the only student who finds these cumbersome by any means.
So on number 2, what is she?
So what did we have? Let's write this one down really quick. So this would be 1, 1. So let's do the order. So -1, -1 was the last one we did. And that moved to, what did we end up at? 3, 4?
Sorry, you cut out. Sorry. Can you hear
Oh,
us?
yeah. Can you hear me?
Yes, we can hear you now.
Okay. So I was just going to write the answer for this one really quick. So for this one, the -1, 1 ended up at 3, 4.
Yeah,
Mhm.
I went
And
ahead.
the 0, 0 ended up at 4, 1.
Uh-huh.
And then the 1, 1 ended up at
4, -2.
1, 2.
Okay.
Oh, I think it's 5 actually, because it was already at 1 over.
Oh
so
yeah, I was wondering why I was wondering because like you said we had to lift it up 1 still, so it should be
Yeah.
3, 4, 5. Okay.
5.
yeah, so 5 -2 instead of 4 -2, because it was already 1 over and we moved it 4 over.
Okay. 4 + 1 is 5.
Yeah, because that one we moved 4 over, we reflected it, tripled it, up 1.
Okay.
Okay, so let me get rid of, see if I can
Yeah, you should write that little thing down.
not erase everything this
1
time.
right. Oh, okay.
Oops.
But steps is number 1. That's not 2. That's number 3.
I do remember doing this.
Okay,
So I'm
so-
going to just get rid of these because a lot of this is going to be the same. So now when we do this next one, it's still the same parent function. So you still want to go off this green graph.
We're still going to use those same -2, -8.
2, 3.
Yeah, this one stays the same because this is another cubic. So if it was a square, you'd start with a parabola. And if it was just an X, you'd start with a line. So if you had a y equals x, if it was something squared instead of these cubes, you would start with 0, 0, 1, 1, 2, 4. You'd start with this graph. You'd start with a parabola. Does that make sense?
Mhm.
So if this was instead of being a cubic, it was a square, you'd start with this.
Okay.
Where?
And if it-
Oh, okay.
And if it was a y equals x, you do everything that we just did, you just start with a line first that went through, you know, just a regular, like a basic y equals x line.
Okay.
So if it didn't have a square or a cube on it, you'd start with a line. If it has a square, you'd start with a quadratic, with a, you know, just a little parabola. And then this one starts with this cubic. Okay. So on this one, what does this one do to the parent graph?
Okay. So that's what I think I was trying to ask you, but I think it was muted.
Okay.
So it says a half. Is that a vertical compression?
You got it.
Okay.
So that'll bring it into the
Yeah. So it brings it closer.
right. Instead of
Okay, so-
moving it away by 3, it'll bring it in.
Okay. to bring them
Okay, so the
then-
-2 will move it.
right,
You got it? Okay, right 2,
and then down 4.
Write it down.
down 4. We'll do that last. And then, like you said, the 1/2 will compress it by half
Right.
or shrink it, or, there's different ways to think of it.
Yeah.
You could say it's going to half it. I mean, it's just however you want to think of it.
Yeah.
But I guess if she asks any kind of multiple choice questions on your test, it'll probably say compress. So compress would be bringing it in, and stretch would be taking it out, like we were doing.
Yeah.
Okay, so the orange one is -1, 1.
Mhm.
Be smart about this so we don't have to write so much. The pink one is 0, 0. And the blue one is 1, 1. Okay. So when we're done with these, we'll write the answers. Okay. So the 1, 1, we're going to go right to. And then compress by half. Where's that going to put it?
Closer to the. Is it closer to the Y?
Yep. No, closer to the X. Or always,
Closer to-
yeah, that number on the outside always. There's no, they don't do any of these on any of these problems. You can do a horizontal stretch, but that would be a number on the inside here, and they never did it. So I wouldn't worry about it. It doesn't look like they're really going to give you one, even though they mentioned it. See this spot right here? They never put anything there. So I'm thinking on the test you probably won't have one either. Okay, so that would be, so it's going to bring it half, which means it's going to bring it, so if we go over 2 and we bring it half, that's going to be at like 3/2. 3 for X and half for Y. Does that make sense?
1, 2, 3.
How do we get over there again?
So we did right 2. So we started with this point. We're starting with the 1, 1. We're going to go 1, 2.
2.
And then you're going to come half as close to the y-axis, to the x-axis,
Okay,
which
right.
puts it at 3/2. And then you got to go down 4, which is weird because we're in the middle of it, like we're at half. So going down 1 is going to be here. You're starting at half and you're going down 4, so you're going to be at like 3.5. It's kind of hard to see it, but it's going to be like here. Because you're going to go to half, 1.5, 2.5, 3.5. So it's going to be at 3, -3.5, or -7/2. Do you know, what does she typically, or she? Does he usually want like 7/2, or is 3.5 okay?
I'm not sure. I did think he just wants it to be like as simplified as possible because I think he does take points off of it if it's like too big, like try to condense it down.
Yeah, so you wouldn't want like -3 2/4 or something like that. I just wonder if he wants a whole number or a decimal, or because I mean you could write that -3.5, you could write it -7/2. We'll just leave it -3.5. But you're okay, you realize you know how to switch it if you have to, right?
Yeah.
So this is a mixed number. If it says as a reduced fraction, then you'd write it as -7/2. And if it says as a decimal, you'd write it -3.5.
Yeah. And a lot of times I just choose to write it as decimals just because I don't like fractions.
Yeah, nobody does.
Yeah.
Okay, so I don't even like fractions. Okay, so 0, 0. We don't have to worry about this middle step. That doesn't affect it. So we just have to go right 2, down 4.
Four. Okay. So we'll be there.
Hold on 1 second. Let me holler at my kid really quick. Logan! Logan! Would you let the cat out?
So does that mean I would have to go right to 1 and 2?
She was meowing. So this one's going to go right to half as close and then down 4. 1, 2, 3, 4. The compressions get really messy because it brings it all in. So these points are only 1 apart from each other as it is, up and down. So now they're only half apart from each other, which gets to be really, so the graph is like,
Yeah, really.
it's, it's really flat. It's flattened it out. So I'm not going to try to draw it because it's kind of hard, but if you drew it, it'd look like that. It's really flat compared to the original one. So you okay with you got that point down? I just erased it by accident. So it was right here. So it was at 1, -4.5.
Okay.
See how this one's just a half up and this one's a half down? They should be symmetric like that.
Okay.
So we went over 2, brought it in by halfway, and then we went 1, 2, 3, 4 down.
Oh, okay. And I see. Okay. Because again, I was wondering like, oh, well, why couldn't it just be like, just like keep it there? But then you said it's a compression, so it has to be brought in.
Right.
Right. Okay.
And then the pink one, the 0, 0 ended up just 2 over 4 down, which puts it like right in between these two.
Mm-hmm. Oh wow. Oh wow. Yeah, you're right. That is really.
So it's like really squished.
Yeah.
If you try to actually draw the graph, it's really hard because it's so flat that it's hard to even draw it.
Mm-hmm.
Okay. So what's our last one? Oh, good. The last one we don't even have. We have a reflection, but we don't have any none of the other stuff. Okay. So, oh shoot, I could have left that. So again, when you do these, if you're starting one fresh, we're kind of doing the same thing over and over. So I'm leaving it there. But remember, the first thing, when you looked at this one, the first thing you would have to recognize is that it's a cubic.
Right.
And so it starts with this parent graph that's in the green, the -2, -8. Like you have to have that to start with, or you don't know where to go. Does that make sense?
Mm-hmm.
Okay. So you got to have that first. And then what's going to happen on this one?
Okay. So it's going to be a reflection, and then it's going to go to the left 3, and then it's going to go up 2.
Right. And make sure you do it in the right order. So
Right.
which one's going to happen first?
The reflection? Or no?
I would do it actually, in this case, it doesn't matter. But just to be in the habit of always doing it the same so you don't get it mixed up, I would do the left 3 first. Start on the inside.
Oh, because it's in the parentheses?
Yep. So start inside.
Oh, okay. I kind of read it just as it comes. So I see like, okay, reflection, and then I go like left to right, but just,
Yeah.
okay, I understand. Okay. I got it.
Okay, so reflect, and then you said, what's the 2 gonna do?
Go up.
Yep, you got it. Okay, so let's start with our 1, 1.
Ooh.
Okay, so where do you think that one moves?
Okay. Let's see. One. Okay. So we have to move it to the left, right?
Mm-hmm.
We have
And
to-
the y-intercept would, or the y-axis would be 1, and then 2, 3. So I'd put it like here.
Okay. 4, 3. So it'd be like 4, 3.
Mm-mm. You mean for the final? Oh, did you reflect it?
Oh no.
So you got to go left 3, 1, 2, 3. Then you got to reflect it, which is going to bring it down here.
Are you struggling with the reflection?
Yeah. So.
Reflection, just like a mirror. So wherever it's at above, put it below.
So a reflection can be across the y-axis and the x-axis?
It can, but it doesn't look like they really have given, like none of your examples have that. Or that reflection would be in here, but it'd be this 1 over b thing, but they're not giving you any. Like they didn't do it in any of these examples because it's hard. It's the hardest. But yeah, if it was inside here, it'd be where the 1 over b is at. But they didn't give you any. None of these had that. It's the hardest. I doubt it's going to be on one. Well, unless he's being really mean.
Okay.
So this one's strange because you reflect it. So you're here, right? When we moved 3 left, then you reflect it down here, and then you go up 2, which puts it right back where it was. So it's at -2, 1 is where it ends up at. So 1, 2, 3, reflect, up 2, right back where we were. You okay with that?
Yes.
Okay, so let's do the same thing here. So we're going to go left 3, 1, 2, 3. The reflect doesn't matter because we're already on the axis, and then we're going to go up 2. And what the reflection does is it ends up putting the blue point below the orange point.
Okay. So we have that there. Okay. So for 0, 0,
Mm-hmm.
is it?
So that one going to end
I
up
have,
at.
yeah. So I have 3, 2.
You got it. That's right.
Okay.
Because you go 3 to the left, the reflection doesn't do anything, and then you go up 2, and you're right there.
Okay. Thank you. Okay.
All right, give the -1, 1 a -1, -1 a shot.
Okay.
Uh-oh, are you still there? Hello. The computer die?
Yeah, I'm so sorry about that.
That's okay. I'm just glad you were able to get back on.
Yeah. Is your computer still on? Oh, I guess it wouldn't affect yours, huh?
Yeah, no, mine's good. And mine's not a laptop, so.
Okay. For that last point for the -1, -1. Uh-oh, did you hear me?
Oh, it lose. Yeah, I'm still here. I'm just
Okay.
being sad because it lost all our writing. Okay.
No.
Oh, but I had -4.3.
I had -4.1.
I think you forgot to go up 2.
Up to. Oh, you're right. You're right.
So you did the 3 left, then you did the reflection.
Wouldn't it? 1, 2, 3. And then.
We'll do just that last one. So we had, so it would have started at, oh, come on. I think my tablet has a dead spot in it. Dang, I've used it so much. Okay. So we were at -1, -1. And that was our orange one. Okay, so we went to the left 3. And then reflect it would put it here, right?
Mm-hmm.
But then you still have to go up 2.
Yes.
So
I did.
ends up at -4.3.
Hmm? No. Well, what?
So I think the answers would be -4.3, -3.2, and -2.1. Did you have all those down?
Yes.
Okie doke. So I would just say, before the test, just kind of remind yourself the order. Don't forget the order, and don't forget to do all of them. Every once in a while, you want to skip the reflection, or you want to do the reflection and then you forget to do the up or down. So just make sure that you do all of them.
Yes, ma'am.
All right, let's look at the next fun topic. You said you kind of wanted to do the.
I think it was 6.2.
This
Just
one.
because this was 6. Yeah, this was the first one we did was 6.1, and 6.2 I thought would be the next best thing to jump to.
Yeah. So this is. So I'm going to use a little bit different terminology on this. I mean, they're using very strict, proper terminology, but I think there's some terms that make it a little easier to think of. So the biggest thing you have to notice first when you look at these is whether or not the whole thing is, why does this keep popping up? Can you see that open with zip extractor thing?
Yeah.
I don't know why that keeps popping up. Like, go away. Anyway, okay, so if you notice what the total degree is, that's helpful, but the biggest thing is what's on each one of these. So I'm going to actually add in something here. Okay, so we're going to talk about what we just talked about. We just talked about like a cubic, and you've talked about quadratics before, right?
Yes.
Okay, so a quadratic is a f of x or a y equals x squared, right? All y equals x to an even power, all of those will be like an up up or a down down. It'll be a u somewhat of a U shape. Like this one, I mean, I know it's got these wavy things in here, but see how at the ends it goes down down. So you know overall this has got a total of some even powers.
Yes.
And then the same thing if it's a y equals x cubed, it goes like this, like we just did. And anything that has a total number of powers being odd will do this. One will go down and one will go up. So it'll either go down, up, or it'll go up, down. So when I look at these, the first thing I do is I add them all up and I write down whether or not they're going to go up, up, down, 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 up. Like that's helpful. And they don't mention that here at all. And I don't know. And I guess it does right here. But it doesn't really say why. So anyway, this is why. Anything that's even, total even, will be like a quadratic, up, up, or down, down. And then anything that's total odd will be down, up, or up, down.
Mm-hmm.
Okay, so when you look at like this one right here, the powers are here. Can you see this? This would just be a 1 and this is a 3.
Mm-hmm.
So this one has a total degree of 4. And so it's going to be like a quadratic. It's going to go up, up, or down, down. So now we got to decide, does it go up, up, or down, down? Well, it's got a negative 1/5 here. And it's negative, so that means it's going to go down, down. We don't know what it's going to do in between here yet, but at the end it's going to go down, at the other end it's going to go down. So that's what that negative does in front of it. And then what these are trying to get at, we'll put this over here. If when you're looking at the power or the binomial, if you have one of these, if it's odd, it's gonna well, let's start. Yeah, if it's odd, it's gonna go through the x-axis. And if it's even, it's gonna bump. They say what do they call it? They call it a tangent. But it basically is going to go up to the x-axis and is going to bump off of it.
Okay.
So anything that has an odd power is going to go through it. Anything that has an even power is going to bump it. So then if we make our basic graph and you mark everything that you know, so we know it's going to go down, down, which we can kind of mark here. We know it's going to have, oh, and where are the zeros at? Do you know how to find the zeros?
They're not, are they talking about the origin?
I'm sorry, the roots, just like where it's going to cross the x-axis at.
No, I don't think so.
That's this right here. See the x plus 3? That means it's going to cross the axis at -3 because -3 would make this 0.
Not +3?
It's the opposite because it's whatever makes it 0. So since it's x plus 3, it's -3.
Oh, okay.
So that's saying that this is going to cross the x-axis at -3. So I'll put that in orange so we can kind of keep track of it. So it's going to cross at -3. What about the other one? What about the x minus 1?
So could you ask that again?
The x minus 1, where's that going to cross the x-axis at?
+1?
Yep.
Okay.
So that one's going to cross at +1. So this orange one, circled orange one, is going to cross at -3 because that's what makes that one 0. This one's going to cross at 1 because that's what makes that one 0. And then we have to determine whether they're going to bump or cross. So this one, it is a is that a cube or a oh yeah, it's a cube. Sorry, I couldn't see it very well. Okay, so this is a power of 1, so that means it's going to cross. Remember, anything that's odd is going to go through the axis. So it's going to cross here, and then what about at the pink one?
It's not, is it going to cross through it too?
Yep, because it's odd also. So you have a 1 and a 3, so they're both going to just cross through. So I sometimes, again, just ways to remember it. I always tell my students, like if it's going to give yourself like a different, something different, like if it's going to bump, put a little star, and when it's going to cross, put a little dot. So we've got dots. So we'll say, okay, for our sakes, we'll put dots when it's going to cross, and if it's going to bump, we'll put a little star so that we can remember it. But these are both going to go through, so we'll just leave them alone. And then we go ahead and we just sketch it. It's not going to be perfect. The other thing that you can do is you could put a 0 in there. So does it make you do that? Nah, it doesn't make you do that, so let's not worry about that. So we know this is going to start down, and then it's going to come through this, and then it's going to come, it's going to turn and come back down this way. See, they don't ever talk about, you can put a 0 in here. This is why how they're getting, you know, that it crosses right about there. They probably put a 0 in there. 0 would be -3, like -3/5. 0, -3/5 is where it crosses here. So it's going to go up, and then it's got to come back down, and then it's got to go through this one and go back down. So the general shape is something like that. I know mine looks horrible, but that's how we know it does all that stuff. This is because the total overall is odd, or even, I mean, and negative. That's what makes it go down, down. It crosses through here because it's got an odd power, and it crosses through here because it has an odd power. So we know it's going to go up and then back down like that. They left a lot of information off of this sheet. Okay, anyway. So let's try another one that's not already done.
Okay.
So,
Like the ones at the bottom?
yeah. So on that one, what's the total degree? You're looking at these.
Oh, there we are. Total degree. Ugh.
So just add up all the powers. So you have a 2, and then
Mhm.
what are these, even though they're not there?
Are those also like those are also powers?
They're just powers of 1, so they don't put them in there. So you know how like x plus 3 was to the first power? These
So
are
it's
to
like
the
4?
So this is a degree 4. Now,
Okay.
is it going to be? So it's like this one. Okay. So is it going to be up, up, or is it going to be down, down? And the way you do that is you look at the front. There's nothing negative in the front. Like this had the negative 1/5.
Mhm.
This one doesn't have that. So this one's going to be up, up. Because it's going to be like this, but it's going to be upward
Oh, okay.
because there's no negative on it. So total degree 4. So it's going to be like a quadratic. It's going to be up,
Uh-huh.
up. And it's not going to be flipped over because there's no reflection in front of it. So now we need to decide where the zeros are at, if they cross or bump.
Mhm.
So where are the zeros at? What about for this one?
-1.
So we're going to have,
Oh wait, no, is that not right?
yeah, that's right.
Oh.
So we're going to have -1. And is it going to cross or bump?
Is it gonna cross?
Look at the 2 on it.
Oh, it's gonna bump?
Yep. So let's put a little star there because that one's going to bump off of it. It's not going to actually cross through it.
So like for instance, if something was like cubed, would it bump too?
Yep.
Okay.
Oh,
So it's-
no, anything odd's going to go through.
oh, okay. Odds
Just
gonna go
evens the
through.
bump.
Okay.
I always think of it as like a 1 is like normal, and that just goes through. And then a 2 is weird and it bumps, and then a 3 is back to normal. I don't know if that makes any sense, but that's what I think to myself.
Uh-huh.
Like the starting point is just to have a power of 1, and that just goes through. Okay, so that one's gonna bump. So we'll put a little star to remind us to bump. What about the x minus 2?
It's gonna cross. I mean, bump it +2.
And it's gonna bump or cross?
Bump.
It's just gonna cross because it has a power of 1.
Oh,
So anything
right.
that's an odd power is gonna just go through. Okay, so what about the last one? The x minus 3.
Okay. Odd power goes. It goes through?
Yep. So that one we'll just put a regular dot. So these ones will go through. This one will bump. And we know it's got to start up, up. So we've got enough to do our sketch now. So we're going to come, we know it's got to go up, up. So we're going to come from up here. We're going to bump, come back up and cross, come down and cross again, and back up. It's going to look something like that. Let's see how this one I didn't cross it. I just bumped off of it. So I knew it was up here and up here. So I came from here and I went bump, turn, through, turn, through.
Mm-hmm.
And that's everything they're asking you. They're just asking you if it's crossing the axis or if it's tangent to it, bumping it. Does it go, you know, what do the ends do? So like the ends on these go, they might say, you know, what does it do at the ends? You would say up, up.
Mm-hmm. Okay. Okay.
It's not quite as bad as it seems. When you first look at these, you're like, what are they talking about?
Yeah.
It's all just foreign
Gibberish.
gibberish. Yeah, it does. And again, that these worksheets are not very detailed. They're just like, and so this is that. Well, how come? There's like nothing that says. Anyway, okay, I'll stop complaining. All right. On this one, what's your total degree?
5.
Yep. So it's a degree 5, and we're doing this right here. So is that going to be up, up, down, down like a quadratic, or is it going to be down, up, up, down like a cubic?
Up, down.
Yep. It's going to be, and it is going to be up, down. A regular cubic is down, up, but this one's going to be up, down because it's got a negative in front of it.
Okay.
Instead of being like this one, it's going to be down or up, down. So instead of down, up, it's going to be up, down. So it's going to flip it. So I always go over to the graph and do something like this on the graph just to kind of remind me of it. Okay, what about the x minus 3? What's that going to do? It's actually x minus 3
Yeah.
cubed.
X minus 3.
Or I'm sorry, x plus 3 cubed.
Yeah, x plus 3?
Yeah.
Okay.
So where's that going to cross at or bump at?
-3?
Yep. And then is it going to cross or bump?
It's going to cross?
Yep. So that one's going to cross at -3. And then what's the x minus 2 squared going to do?
It's also going, oh wait, no, it's going to cross at +2. And it's going to go, it's going to bump?
Yep, because it's an even.
It's even.
So evens bump. Okay, so we know it goes up here, down here. We know it's going to cross with this pink spot, bump off that orange spot. So we're ready to sketch it. So it should come downward, cross, turn, bump, down. That one's kind of boring, actually.
Mm-hmm.
And every time it crosses or bumps, it does a turn. So you know, like it's not going to just keep going down and down. Once it goes through there, it's going to turn around and come back. And once it hits that bump, it's going to come back down again. So.
Okay, there we go.
I'm going to try moving this up a little bit. Whoa, that's not what I meant to do. Hello. Shut. All right, it doesn't like it when I do that, so I'll quit doing that. Okay, so let me get rid of this stuff. Okay, so this one down here, I don't know if you can see it. I can see it. You've got the actual worksheet, right? So
Yeah.
you can see it. Okay.
Number
3? Yeah, so number 3. Okay, so we've got, is it x minus 1 cubed and x plus 4 squared?
Yes.
Okay, so what's the first thing you want to decide?
The degree?
Okay, so what's the total degree?
5.
Okay, and what's that mean for the graph?
It's going to be like up, down?
Yep, so it's going to be one of these. And it's it doesn't have a negative in front of it, so it's going to be just like this cubic is. Instead, it's not actually going to be up, down. It's actually going to be down,
Down, up.
Up. Yep, because it doesn't have a reflection to it. So it's going to look just like this one on the ends. Okay. What about this binomial right there? Where is it going to touch the x-axis at, and is it going to cross or bump?
Okay, it's gonna touch at +1 and then -4.
And what's it going to do at the +1?
At the +1, it's going to go through,
Yep.
and then at the -4, it's gonna bump.
Okay. And then you're set. So you go, we know it goes down here on the end, so it's going to go bump, turn, cross. That's it.
Ooh, okay.
It's like they did the hard ones first and then did the easy ones at the end. Now this last one, this is got a ton going on just because it's got 2, 3, it's got 5 different things in it.
Mm-hmm.
Are you okay with 3? Sorry, I just kind of.
Yeah, no, yeah, you're right. That one was a little bit easier.
Yeah, so once you get the bumps and crosses and the directions, that's really all you got to have. Okay, so on this last one, this one's kind of a pain just because it's got so many terms.
Yeah. Oh, yeah.
So we've got to go through and get a total degree.
Yeah, so how would I do that? Because this one doesn't have any of the little, not exponents.
Yeah, exponents, powers.
Oh, exponents? Oh.
Yeah. It doesn't have any because they're all what? They're like these ones are. What do we say the powers on these ones were?
Hold on. Sorry, what?
So up here on number 1, when you had the x minus 2 and the x minus 3, what did we say the power was?
Oh, 1?
Yep.
Oh, I see.
So these are all ones. X to the first, x plus 3 to the
So
first.
So it'd be a degree of 4?
You have to count the x also. You don't have to count these numbers because they're not a variable, but the x you do.
Oh, okay. So 5?
Yep, so this is another degree 5. Jeez, I got boring with that. Okay, so another degree 5, reflected or not reflected?
5. Not reflected?
Yep, no negatives in front, so it's going to go just like this one. It's going to go down, up.
Right.
Okay, and then we just have to get all these things. So where's, this first one's kind of tricky because I never gave you any examples like this. So where would an x equal 0 at?
The origin?
Yep. So this is like x minus 0, basically. So that one's going to be at the origin. And is it going to bump or cross?
Ooh. Would it cross?
Yep. In fact,
No.
all
Oh,
these.
would it,
Yep, all of them do because they're all first powers and odds just cross. They just go through.
oh. Okay.
I keep saying cross, but I have written through. But yeah, so it crosses the x-axis. Okay, so then we just have to do that for all of them. But they're all going to just cross because they're all powers of 1. So
Okay.
the x plus 3 is going to cross at -3.
-3.
Yep. And the x plus 1 is going to cross at
Hello?
I'm there. Where's the x plus 1 going to cross at?
Oh, -1?
Yep. So that one crosses at -1. Running out of colors because they have so many here. Where's the x minus 1 cross at?
+1.
And then x minus 3.
+3.
Yep. So I was going to cross at +3. So this one's going to be, I mean, it's just going to turn, because it's going to start down here, and every one of these is going to go through, turn, go through, turn. So we're going to start down here, come up, It's going to go through that orange one, turn to the purple one, turn to the pink one, turn to the black one, turn to the red one, up. So that one's kind of crazy.
Hmm.
And we don't know how high these go or anything. They don't ask us for that. I mean, we could figure it out, but we'd have to just do some, some table work. We'd have to plug in like a, -2 or -3 to just kind of estimate how high does it get.
Yeah, yeah.
But they
Got
don't ask us that, so we don't have to worry about it.
Mm-hmm.
And that's all for those. So it's actually, I think in some ways it's easier than 6-1. There's not quite as much going on. I mean, you don't have to do all the shifting of the points. This one is just figure out whether it's, up, down, up, whether they bump or cross, and then sketch it in, and you got it.
Okay. Okay.
Feeling a little better?
Thank you so much. Yes,
You're
much
welcome.
better.
All right, so let's go
Thank
look
you
at
so
this other
much.
one. Now this one, this is actually super easy other than
Yeah.
multiplying it out. So
Okay.
this is a matter of, are you good at foiling and such? Because the concept isn't hard.
Okay.
It's just that they have you multiply it out. Sometimes some books won't even bother with having you multiply it out. They'll just have you leave it. Like they'll just have you leave it in the long form. But what this says is that if you have one complex root, you have to have the other complex root. So if we know that 1 minus 2i is a root, then 1 plus 2i has to be a root also. So they may only give you one, but you have to realize that both of them. So like here, the complex conjugate of this would be 1 plus I. This one would be -1 minus 3i. You don't change the number in front, only the number, the positive or negative in the middle. And then this one's like 0 minus 2i, so its conjugate would be 0 plus 2i, or just 2i. So the conjugate of -2i is 2i. So let's not rehash this one. Let's just do one of these.
Oh, wait, that's it?
Well, that's for those ones, yeah. They just want the
Oh.
conjugate. So 1 minus I is 1 plus
Oh,
I.
so like the opposite kind of?
Just don't change the sign in
Ah.
front. Only change the sign in the middle. The sign that's in front of
Okay.
the I is the only one that gets changed.
Ah, okay. Duh, sorry.
And the reason they're called conjugates is because when you multiply them, they get you a real number. So even though
Yeah.
they're not real, if you multiply them, you get a real number, because 1 times 1
I
is
see.
1, and then you get minus I plus I minus I squared. Well, these
Right.
cancel. I squared is -1, so you get 1 minus -1, which is 2.
Mhm. Okay.
So conjugates, even though they're not real, multiply to get a real. They're kind of strange little beings.
Okay.
Okay, so when we're looking at these, on this one, it says that your roots are 1, -2, and 3 plus I. So that means your function is has got 4 terms. Get rid of this. Okay, so our 4 terms, we're going to have 4 terms. Our first term is going to be from this 1, and in order for it to have this is the roots. This is like they're giving you like where it crosses the x-axis at, basically, like from that other worksheet. So if it crosses the x-axis at 1, that means it has a root of x minus 1.
Oh, and in blue, that's how we're going to write it?
Yep.
That's how you write the official answer?
Yep. Well, the start of
Oh.
it, we have to multiply the darn thing out.
Oh, okay. Okay, yeah, I guess it's the biggest thing for me. It's because, like, I didn't even know how to set it up.
Didn't know how to start. Yeah, because if you don't know how to get it set up, you can't multiply it. So the -2, again, it's saying it crosses at -2, so it must have had an x plus 2 for a factor. And then the i's, remember if it has a 3 plus I, it has to have a 3 minus I. So even though they don't list it, it has to have both.
Mm.
And so you're going to have x minus 3 minus I and x plus 3 minus I. You're going to have both of them. Oh, sorry, don't write that down. Crazy lady. Okay, this is still a minus, but this is a plus. So you have an x minus 3 minus I and an x minus 3 plus I.
Okay.
Because they're kind of like the 1. So it's, it's x minus it.
Mm-hmm.
There's a 3 minus I and a 3 plus I.
Oh, okay.
So now we have to multiply this whole darn thing out. So I'm going to do these two first because they're super, they're so much easier. It's just a FOIL like you've been doing since, the third week of Algebra 1. So that'd be like x squared. Then you'd have a plus 2x and a minus x. So plus x and then minus 2. Are you okay doing those in your head? Some people are and some people just can't.
Yeah, for me, I have to write them down just because I am very visual.
So let's just write them out. So it'd be x squared plus 2x minus x minus 2. And then these I'm just going to simplify. I'm not even going to try to multiply them yet. So this one, the minus on the outside is going to distribute through. So it's going to be x minus 3 plus I. So x minus 3 plus I. And then this one, the same thing, that negative is going to distribute through, so it's going to be x minus 3 minus I.
Okay.
And I'm doing it a little bit different than they do. I think the way they do it is I think it's very hard to follow. So I'm doing it a little bit different way, but it'll end up with the same thing. Okay, so this one in the front, all we have to do to simplify that one is x squared, put the two middle terms together, and that front one's done for now. And we just have to deal with this mess. And this isn't really FOIL because it's got 3 terms and 3 terms. It's like a multi-distribute. So you're going to do this one times all 3. Then you're going to do the 3 times all 3, and then you're going to do the I times all 3.
Oh, geez.
I know, it's kind of a pain. So are you okay with the x minus 3 plus I and the x minus 3 minus I? Were you okay with that?
Yeah, I think. I mean,
Okay.
it seems kind of straightforward.
Okay. Well, some students forget to distribute that negative. So, okay, so x times x is x
2x?
squared.
Oh, x squared, okay.
Yep. And then x times negative 3 is going to be negative 3x. And then x times negative I is going to be negative ix, which will end up canceling eventually, but we won't do it quite yet. Okay, so then we're going to do, that was the x times everything. Now we got to do the 3 times everything. So like this. So that'll be minus 3x plus 9 plus 3I. You have to remember that's got a negative in front of it. So negative 3x -3, +9, -3, -I, +3i.
Mm-hmm.
So far, so good?
Yes.
Okay. And then we got to do it again. So we're kind of running out of spots to be able to draw it here, but you got to do the I times everything. So I times X is just IX. I times -3 is -3x. Or I'm sorry, -3i. And then I times -I is -I squared. And so that's what I mean. Like, this is the hard part right here, is just making sure you don't lose anything in here. You have to keep all your
Yeah.
signs straight, and yeah, it's a pain. So I always just kind of go through and visually look at it real quick too. So I got x squared, -3x, -ix, -3x, +9, +3i, +ix, -3i, -I squared. And I just kind of, visually look through it one more time just to make sure I didn't make any mistakes. So now we got to simplify this. So go through and look for anything that's opposites of each other, and we'll get rid of them. There's a bunch of them. Well, not a bunch, a couple. Like this. -ix and a +ix.
Mm-hmm. Oh, because they just simply cancel each other out.
Yep.
Oh, I see.
And then we've got another, there should be another one here.
Let's see if I can find it. Is it, no, hold on. I see, don't we have two -3x's?
We will, and we'll combine those, but they don't
Yeah,
cancel
those are
each
going to
other.
be combined. So, 3i and negative, no, is it, oh, I see it. Yeah, I see it.
Yep. Those are gone. And so now we can combine. Okay, so that gives us, we got an x squared. Oh, and then the -I squared, we can switch to a +1. You okay with that?
Sorry, say it again.
The -I squared can be changed to a +1 because I squared equals -1. So minus a -1 is a +1. So any I squares, you can just switch to the opposite of whatever it is. So since this is a negative, you can switch to a +1. Okay, so now we'll fill it in. So we got x squared minus 6x, 3 and 3. And then the 9 and the 1 makes a 10. So this is the nightmare step right there. The one we just did. And this next one's not wonderful, but at least it doesn't have any eyes in it. And then we've got to do what we did here. We've got to do it again. We've got a trinomial times a trinomial. We have to do.
Oh my gosh.
I know it. Good
Crazy.
times. So you got to do that again. So we've got x to the 4th minus 6x cubed plus 10x squared. Then you do it all over with the x.
So like x cubed?
Yep. Minus 6x squared.
And then 10x?
Yep.
Plus 10x?
And then we just have to do it one more time. So then we have to take the 2 and distribute it through. So that would be negative 2x squared plus 12x minus 20. Sorry, it's getting all on top of that other writing, so hopefully you got
It's
it on
okay.
your paper. Okay,
Mhm.
so now we just have to combine like terms and we're done. Fine. But see, this just gets ugly. This first step is not that bad. It's
Mhm.
multiplying it out that's ugly. Okay,
Yeah.
so we've only got 1x to the 4th.
Mhm.
X cubes.
We have negative 6x cubed. We have an x cubed. That's it.
Okay, so that makes a negative,
7x cubed.
this one's a positive, so it's actually a 5.
Oh, okay.
Because you got negative 6 plus 1.
Mm.
Okay, so now the x squares. There's one there.
And then
There.
negative 6x squared.
Yep.
And then negative 2x squared.
So 10 minus 6 minus 2.
So positive 2?
Yep.
Oh, yes.
And then last but not least, we've got, we've got the negative 20 on the end. There's only one constant. But then we have the positive 10x and the positive 12x.
Okay.
And that should be it. Unless we've made some sign error in there, but hopefully we haven't. This next one's actually easier because it's just a 2i. It doesn't have anything. It's a imaginary number with no real part to it, so it makes it easier.
Oh, okay.
All right. You got that one written down?
Yes, ma'am. Thank you so much.
All right, so let's do this last one. So we just need to go with, what does it start with? So it says negative 3, 5, and 2i. But if it's got 2i, that means it's also got negative 2i. That's what this whole, like the whole rule up here is that if a plus bi is an imaginary root, then a minus bi is also a root. So if I give you one, you've got to include the other. So what are our binomials?
So it would be x plus 3.
Yep.
So x plus 3. And then let's see. Parentheses x minus 5.
Uh-huh.
Okay. And then it is going to be parentheses x x minus 2i.
Yep.
Okay.
And then
Is
x, don't forget the negative 2i. If it has 2i, it also has 2i, negative 2i.
Oh, right.
So we have x minus 2i, and we also have x minus negative 2i, which is x plus 2i.
Oh, can I just put plus 2i or?
I mean, if you want to, at the very beginning, you might want to put, minus a negative or something, but I would just write the plus. This one will be way quicker to multiply out because we don't have the real part over here. These will multiply out way faster. So we FOIL this out again. So that's going to give us x squared minus 5x plus 3x minus 15. And then what do we get over here when we FOIL these out? Remember, this is like a plus.
Mhm. Oops, oops, oops. Uh-oh. Let's see. What are we starting with again? Are we starting with the
Well,
The-
I wrote this out already, so I just FOILed these two because these
Right.
two don't have any i's in it. So I just did, you know,
Mhm.
x squared
right?
minus 5x plus 2. Yeah.
Right.
And then this one, it only has 2 parts to it. So this one is a FOIL. We don't have, it's not going to be as like the other one because it's only got 2 and 2 instead of 3.
So we
and
don't
3.
have to really do anything to that?
Well, we have to multiply it out, but it's just a straight FOIL.
Oh, okay.
So it's just x times x, which is x squared. And then x times 2x, or 2i, which would be literally just 2ix, or 2xi, or i2x. There's really not a, I see different books put those in different order, so. And then this one, negative 2i times an x is just negative 2ix. And then on the end, you're just going to have minus 4i squared. So you okay with all 4 of those terms?
Yes, ma'am.
Okay. So this first one, we're going to combine. So it'll be x squared.
Let's see. Is it going to be negative 2x?
Yep. Minus 15. And then over here, the 2 middle terms just cancel. The negative 2ix and the positive 2ix.
Mm-hmm.
And then do you remember, what do we do? What's the negative 4i squared turn into?
Ooh, I squared. Wasn't it something about like +1 or something like that?
Yeah, because I squared is negative 1, right?
Mm-hmm.
So this is basically negative 4 times negative 1.
-4 times -1. Oh, so 4?
So that just becomes a plus 4.
Oh, okay.
You should never have an I squared because I squareds can always be turned to negative 1s. So we just have x squared plus 4.
Okay.
Because the middle two cancel. Again, this is because it's a number times its conjugate, so it just cancels out the middle. Okay, so now we've got x squared minus 2x minus 15, and we have to multiply that by x squared plus 4. So this one is more than a FOIL because it's got 3 terms. So I've got to take that times both of those.
Mm-hmm.
And I got to take that times
Both
these
of those.
2. And then you got to do the 15.
Yeah.
Okay, so what do you get for the first ones?
Okay. Would it be 2x squared?
Oh,
Hello?
no, it's not. No, I'm sorry. It's not 2x squared. It's, what do you do with the powers?
Oh, you add them?
Yep.
Oh,
So-
so it would be 4.
Yep, you got it.
Okay, my bad, my bad.
So x to the 4th, and then take x squared times 4, and that'd get you 4x squared. And then do the orange ones. What will that get you?
Negative x to the 3rd power?
Uh-huh. Negative 2x to the 3rd. And then,
Okay. And then
times.
negative, oh yeah, oh sorry, that would be positive, no, but yeah, no, sorry, that'd be 8. 8 to the 2nd power?
you just have a 2x and a 4. So it'd just be It'd just be x because that one doesn't have an x on it.
Oh, I'm sorry. I accidentally went one on my paper. Let me erase that.
Oh, so you have an x after the 4? Yeah, get rid of that. It's just a 4. So negative 2x times 4 would just be negative 8x.
Mm-hmm.
And then these last two.
So it'd be negative 15, x to the second, and then it would be, ooh, what is that? Let's see. Would it be negative 11?
No, we want to go ahead and multiply them. So you want to take 15 times 4.
Oh, 15 times 4. So it would be negative 60?
And now we just have to combine like terms and we're done. So there's only one x to the 4th. There's only one x cubed. Negative 2x cubed. I mean, I shouldn't say it like that. There's one x cubed term.
Yes.
One term that has an x cubed. So we have an x to the 4th. We have the one x cubed term, negative 2x cubed, and then we have a positive 4x squared and a negative 15x squared.
Mm-hmm. Okay. And we just put them in order, right? So the next one would be...
Yeah, so I looked for the 4th power and then the 3rd power, and now I'm putting the 2nd powers together.
Mm-hmm.
So what does the 4x squared and the negative 15x squared make?
11.
Yep.
11.
Negative 11.
Yeah, negative 11x squared.
X squared, okay. And then there's only the one x term and the one constant term. So minus 8x minus 60.
All right.
So it's kind of a long answer, but it wasn't as bad as that last one.
Yeah. Okay.
So now you're done with your homework. You have good things to look at to
Ooh.
study before your test tomorrow. And can you use notes on your test?
I would have to check on the official, like, we use Canvas at my school, so I would have to check.
But are you, so you have to, but you're on your, are they doing like a virtual proctoring or anything? Or are you just on your
No,
honor?
it's like no, it's like you just click on like this little test icon and they take you to like a lockdown browser and you do that.
Got it. But it doesn't actually like videotape you while you're taking your test or anything?
No, something
Got
like
it.
that.
So, but yeah, I would just, before you take it tomorrow, I would just remind yourself of, the different steps. And if you could have notes, I would have something that, like what we wrote down, like, an example of like what order to go in and with the graphs, with the polynomial graphs, I would say, first look and see what's the total degree, and then what's where do each of the roots cross at, and that kind of thing.
Yeah. Well, ma'am, I really can't thank you enough. I mean, you really saved me.
That's okay. I feel horrible that your mom said she had 9 kids. I was like, oh my gosh, she's trying to homeschool 9 kids. That's just crazy. And it's not even homeschooling. I mean, homeschooling is a voluntary thing. This was like, this is trying to finish school at home, not really homeschooling. So, well, very best of luck. So, are you at Oak Ridge?
No, I'm at the new high school, Grand Oaks.
Grand Oaks. Okay.
Yes.
Got it.
Okay, well, thank you so much.
You're
I'm sorry
very
it's so
welcome.
late.
It's fine. I'm a night owl, so I'm good. Take care, and very best of luck on your test tomorrow.
Thank you so much.
Bye-bye.
I'm done. Good night.
Good night, baby.